Hello everyone, welcome back. Let's continue with our next topics, that is tensile strength, modulus of elasticity of concrete, shrinkage of concrete, creep of concrete. Before going to these topics, I want to explain about grade of concrete. As I have mentioned in the earlier videos about grade of concrete, I have explained in brief. So, if the concrete grade is M10, M20, M15, that means here you can see the third column, the specified characteristic compressive strength of 150 mm cube at 28 days in Newton per mm square. That means for 28 days the characteristic strength or compressive strength is 20 Newton per mm square, or if it is M15 it will be 15 Newton per mm square. So by knowing only the characteristic strength of the concrete, we can calculate tensile strength of the concrete, modulus of elasticity of concrete, and also shrinkage of concrete. Why I'm telling this is, how can we calculate by using these grade means? See here, in all, no, not in the all, in these two formulas, that is tensile strength of the concrete. The tensile strength of the concrete is having a formula of FCR is equal to 0.7 root of FCK. This is a standard formula for tensile strength of concrete, where this FCK will keep on changing. Okay, that is nothing but the characteristic strength of the concrete. This FCK is characteristic strength of concrete, that is M10, M20, M15, M25. Depending on the grade of concrete, this FCK will keep on changing. So using this we can calculate these formulas, and these are the standard formulas available in the code book. Next one is modulus of elasticity of concrete. Even this will E value will be keep on changing depending on the grade of concrete, and it is not same as steel. Modulus of elasticity of concrete formula is E is equal to 5000 root of FCK, where I said FCK is nothing but grade of concrete. It depends upon the types of the grade given. So this E or modulus of elasticity of concrete won't be constant at all, it will be varying. But always keep in mind, for steel, modulus of elasticity of concrete will be constant. It is 2 into 10 power 5 Newton per mm square for steel. Next thing is shrinkage of concrete. The minimum value of the shrinkage for concrete is 0.0003. So keep this value in mind. If shrinkage of concrete is asked, means what is the, sorry, not a, it's not a minimum value, it's a maximum value, sorry. The maximum value of the shrinkage of concrete is 0.0003 is a maximum value. Next thing is creep of concrete. This creep value we can get, or these formulas, these values we can get from IS 456 2000. Please refer that code book, these are available. From there we have taken a table here, that is creep coefficient. Creep coefficient will keep on changing depending on the number of days. If age of loading is 7 days, then creep coefficient is 2.2. If it is for 28 days, creep coefficient is 1.6. If it is 1 year, it is 1.1. So you can observe, as the days increases, this creep coefficient decreases. It is just a vice versa. It is 7 days 2.2, 28 days 1.6, 1 year 1.1. These are the standard formulas as well as the standard values. Please remember this table and a value. It's important in RCC. So let's move to next topic, that is a code requirement for different elements. That is, for slab, what is the minimum reinforcement provided, spacing, nominal cover, these things are important. So first let me read out this and I will explain it to you. The first thing is minimum reinforcement in a slab. What should be the minimum reinforcement? They have mentioned in a code book, and it is a standard thing. We should refer IS 456-2000 for these details. Minimum reinforcement should not be less than 0.15% of gross cross-sectional area for mild steel, and should not be less than 0.12% of gross cross-sectional area for HYST bars. So keep it in mind, we have two different type of material properties here, that is, one is for mild steel, one is for HYST bars. If we are using, as I know, now in the market we are not using mild steel. So earlier we used to use it. So for a mild steel, the minimum reinforcement should not be less than 0.15% of gross cross-sectional area. Okay, this is a standard thing. That means, for example, what they are telling gross cross-sectional area means, always in slab we consider 1 meter strip, because in slab we cannot take any cross-sectional area. So for that, for 1 meter length concrete, for 1 meter length concrete will be considered, and then for 1 meter length, what is the cross sectional area we will calculate, and according to the depth of the slab we will calculate that, and there will not be any width in the slab. So keep it in mind, it is for 1 meter strip we are assuming like that, and we are calculating. So for 1 meter strip, how much reinforcement should be provided for a mild steel? Okay, so they are talking, they are saying that in a code book it has been fixed that it should not be less than 0.15% of cross sectional area. And always keep it in mind, for mild steel it is less strength, so we are using, or we are increasing the area of steel. You can observe, for HYST bar it should not be less than 0.12%, but for mild steel it is 0.15%. And HYST bars are high yield deformed bars. So we have reduced the cross sectional area, and dia of the bar in the slab should not be less than 8 mm. So just keep it in mind, they have given in the code book here. Okay, it should not be less than 8 mm, or if it is HYST, okay, then it should not be less than 10 mm for a plain bars. If in case we are using HYST, it main bar should not be less than 8 mm. If we are using a plain bars, it should not be less than 10 mm. And about the distributors also, they have fixed standards. Distributors should not be less than 8 mm, and it should not be more than L by 8 of the slab thickness. Okay, it is 1 by 8 into the thickness of the slab. Okay, for example, thickness of the slab is 150 mm, then 150 into 1 by 8 will give you what diameter you will get, that is a maximum diameter that we should be using. This is how we will calculate the minimum reinforcement distributor and all for a slab. Next is spacing. About spacing, it should not be greater than 3 times of the effective depth or 300 mm of the main reinforcement. Okay, always in between these two, that is, it should not be greater than 3 times of the effective depth, that condition, or 300 mm of mean reinforcement. In between these two values, always we should consider a less value for spacing. Okay, keep this in mind, it's important. For spacing, always we go for a lesser value of spacing. The final one is nominal cover. It should not be less than 15 mm nor should not be less than dia of the main bar. If you don't remember this 15 mm value, then how to remember what is a nominal cover should be given? It should not be less than the dia of the main bar. Okay, then maximum dia of the reinforcing bar should not be greater than 1 by 8 of the overall depth. Okay, so if for a nominal cover 20-25 mm up to 25 mm is allowable in slab. Okay, don't give more than that, then that will be correct if we do that. Okay, this is all about the slab. So let me show you the figure. Here you can see that these are the distributor bars. Whatever vertical lines you can see here, these are the distributor bars and these are the main bars. Here the alternate bars are cranked. Observe carefully. Here I will start from here. This is a straight bar and again they have cranked here. Next, second one is up to here, it's a straight bar, then cranked. Like this, alternate bars will be cranked bars. So this is how slab reinforcement is provided. And you can see this, I was talking about this. I have just taken a sample and I am showing it. These are the main bars. Whatever this cranked bars you can see is a main bar. These are the distributor bars. That is what I have represented there and I have shown you. The next thing is, it is a beams. We are all familiar with the dimension of the beam, that is area of the beam is B into D. We know that this is how the beam reinforcement is provided. You can see here. Then about the, here also it is about the reinforcement. Here about the reinforcement you can see it should not be less it should not be greater than 0.2% of gross area and it should not be less than 0.04% of gross area. These values are important. The mean reinforcement should not be greater than 0.2% of gross area and should not be less than 0.04% of the gross area. And generally for beams we use minimum of 4 bars with 2 bars of 12 mm thickness in the bottom of the beam and 2 bars of 10 mm at the top of the beam. They are talking about this portion. If you take this as a cross sectional area, this is a bottom portion, this is a top portion. For top portion, for a bottom portion, minimum 2 bars. I'm just giving an example. I'm not talking exactly what they have given here. Okay. So 2 bars will be main bars. These are called main bars. Okay. So 2 main bars are provided, which is of 12 mm thickness at the bottom. Then again 2 bars of 10 mm at the top of the beam. So this is how like these minimum 4 bars are distributed, and they are saying for bottom it should be 12 mm and for top it should be 10 mm. Next is nominal cover. It should not be less than 25 mm and should not be less than dia of the main bar. At least it should not be less than dia of the main bar. They are saying like that, and it should not be lesser than the 25 mm. Next thing is, you can see a diagram here. See, this is how the reinforcement are provided for the beams, vertically as well as a horizontal, and just I have taken a sample of it and I have showed. This is how beams reinforcement are provided. The next thing is, it is about the column. For the column, the minimum reinforcement should not be less than 0.8% of gross area, and maximum reinforcement should not be greater than 6% of the gross area. Keep it in mind. About minimum, how much should be the minimum they are telling first. So minimum should not be less than 0.8%. It should not go, reinforcement should not be below than 0.8%, and it should not be greater than 6% of the gross area. And for a column, the number of minimum bars for a rectangle column is 4, for a circular is 6. Keep it in mind. Many times in exams, any competitive exams, these values of reinforcement, about the minimum and maximum reinforcement values of beams, slabs, columns are important. So keep it in mind. For column which is of rectangle shape or section, 4 is the minimum number of bars. For a circular bar, or circular column, it should be a 6 bars used in a circular section. Next is, minimum size of the dia should be 12 mm and minimum cover is 40 mm. For column, 40 mm cover should be the minimum and 12 mm should be the minimum reinforcement. Next is lateral dia of the bars, that is stirrups. They are okay, I will show you in the next slide what is that stirrups. Okay, in beam I didn't talk about the stirrups. These are the vertical lines are a stirrups. What is running like this? It is a main bars for a beam. Then for a column, lateral dia of the bar or stirrups should not be less than 1/4 of the dia of the main bar, and it should not be less than 5 mm. Keep it in mind. Suppose if we use 6 mm dia for the main bars, okay, so the value will be 16/4, means 4 mm. It should not be, stirrups should not be less than 4 mm, okay, usually, but we don't use 4 mm dia bars for stirrups. We should follow the code books or codes. Minimum minimum dia will be 8 mm, okay. So that is a important point here. Next is about the pitch. For a pitch, uh, again we have a standards. First of all, the pitch means spacing between the lateral stirrups is called pitch. Let me okay, here these are the stirrups, or you can see here these are the stirrups, and these vertical lines are this here, whatever dotted kind you can see here in the top, those things are main bars, and these lines are stirrups. The spacing between those two lines are called as pitch. So the least um, lateral dimension of member means, suppose if we have an column of width 230 mm or 300 mm, first pitch we need to consider that as 230 or 300 mm. They are saying least lateral dimension of members should be taken. That is one thing. And next is 16 times smaller dia of the longitudinal bars. If in the column, if we are using 12 mm and 16 mm, in these two, whichever is the least, we should consider that. So it is a 12 mm. Okay, 12 into 16, that is a value we need to take, and they are talking about that. 16 times the smallest dia of the longitudinal bar. Out of 16 and 12, 12 was the minimum longitudinal bar value. That into 16, 12 into 16 will give you some value. We should consider that. The next option is 300 mm. And first of all, whatever least value we get in these three, that value will be, or that will be the pitch for the stirrups in the column. These are just a condition. In these three conditions, least value will be taken as a pitch. Hope you have understood the specifications of slab, column and beams. This is how the cross section will look. As I mentioned, for a rectangle column, the main bars should be of 4. That is a minimum. You can see here 1, 2, 3, 4. These are the cross section. That means it will look like this. If we cut this, if we see the cross section, it is something like this. Okay. So for a rectangle, it's a minimum of 4, and if it is a circular column, it will be 6 numbers in for main bars. So that is how the columns are minimum reinforcement are provided for the different structural elements. Okay, thank you so much.